taking the time out to join us today. So we will, as I say, get started if things want to work today. There we go. So welcome along. Good morning, good afternoon, or good evening from wherever it is that you are listening in from in the world. Welcome to the first in what will be a bit of a series of webinars, we hope, from Hall Technologies to ramp up our education offering. It's humbling to see some of the people who decided to join us today and just how many of them of you there are. So thank you very much. As I say, based on feedback from today, we will look at what it is that we go on to cover next. My colleagues Roy and Josh are in here. I think we've actually got Ken Eagle, our VP of technology, in here as well. So there's a good group of people. There's a great group of brains who are able to hopefully answer any questions that you've got across the coming 45 minutes ish that we're going to be running through some presentation slides for you. So just in case anybody doesn't know who you've come to listen to today in terms of Hall Technologies, we are one of the one part of a group of four of the oldest companies within the AV industry. There are only 3 companies within this space who are more experienced than ourselves in doing what we do. The company split into 2 main parts, 2 main industries, into medical, where we are one of the largest suppliers worldwide of medical grade electronics to 2 of the largest medical equipment manufacturers in the world. And then we have the Pro AV side. And I think I like to categorize that as signal distribution, so USB, HDMI, using technologies like HDBaseT and AVoIP, and then our unified communications offering, which is something that has been with us for, I think, over 12 months now, really, and has been where we've kind of forged forwards with new product. If you don't know who I am, my name is Daniel. I am part of the technical team here at Hall Technologies. Yeah, I think there's a lot of you guys from the States in here. It's one of those things of who's he? Well, out this way, hopefully, a few people know who I am. Thankfully, if anybody's joined us from the EMEA, I've been in the key custom install industry for 20 years now. So 4 years as an integrator in the UK, drilling holes in 2-foot thick stone walls out in the countryside in the middle of the UK. And then I've had 16 years as a technical director to 2 video distribution brands and a distribution company based out here, and a worldwide brand, I would say, and one brand that perhaps covered maybe half the globe in both residential and in the commercial side. Moving to Hall Technologies is a step very much into the Pro AV side for me, somewhere I've not been before. So I am on as much of a learning curve, I think, as perhaps some of you guys are today, which is great. It's all good. It's what we want to do. You have also, we've mentioned, we've got Josh in here, who is a bit of a Jedi when it comes to helping you guys out, plan systems, in managing things in post support as well. He is nothing short of a legend. As I said, we've got Roy. If anybody from the EMEA knows Roy Leggett as our sales director as well, and I'm pretty sure we've been joined by Ken Eagle, who we can get involved if we need to help answer your questions. Bit of housekeeping. Everybody's microphones are muted for the duration of the presentation today, just to stop any background noise coming in and disturbing anybody, making sure you can kind of all hear me, hopefully to the best of your abilities. If you have any questions, as Josh said, feel free to use the Q&A feature that's built into the Teams webinar software. Now, I've highlighted what that button looks like on screen for you now. You've also got the ability to raise your hand. So as soon as we spot those, I think that's going to be Josh and Roy who are keeping an eye out for those. Then we can always unmute your microphone and have a question come in from you. And I don't think you've got the chat option. So it's going to be raising your hand and it's going to be that Q&A box. If it's a question I'm going to be answering later on in the presentation, I'll let you know that. If it's something we can answer there and then we'll do that for you as well. And of course, there's going to be an opportunity to ask questions at the end of the session. And we might leave some of those that if anybody picks up anything during, leave those till the end of the session as well. Perfect. So we will get started. So before we just kick off properly, just to give you an overview of what we expect you to, what we want you to take away from today's session. Okay, we're going to be covering basic overview of each technology that we're talking about here, HDBaseT and AVoIP, how they work, what applications each would typically be used for. We're going to have a little look at, we'll mention the potential benefits and the pitfalls of both technologies, things like why we potentially choose to use these instead of designing a system with pure HDMI infrastructure, that kind of thing, that kind of message is going to come out. If we can get 3 things into your minds today, and you can take away 3 things from this piece of learning, then we've succeeded. That's as much as any human brain likes to take away. Then we've won at that point. So the average person is going to pick up and retain 3 things from an activity like this. So let's see how we do and see if we can get some 3 key things stuck in your mind. So for the purpose of being technically accurate as possible, there's obviously some Hall Technologies product in here, and we're just trying to keep it as agnostic as possible today to give you the best value agnostically as possible. But you are going to see obviously Hall Technologies product pop up here and there. So just to keep you ahead of that. Brilliant. Point 1, don't panic. If anybody recognizes that logo, I'm hoping that translates between the USA and the UK. So Douglas Adams' Hitchhiker's Guide to the Galaxy, if people don't know. But if you don't understand everything that we're going to go over today, don't worry about it, okay? It's difficult to know the skill set of everybody who's joined us today and whether we're going to be pitching our learning above you or below you. If we do, then get in touch with us after the session, okay? If you feedback to us and you say, look, that was I need more depth, what have you got? And then we can help you do that. If people need to go right back to basics, then come to us, let us know. We are more than happy to do all of that type of training and either do that to small groups. We can get on one-on-one calls, whatever it is that you need to get the learning at the level you want, just let us know. So hopefully, though, there is something for everybody in here. If it passes you over, don't panic. There's a little bit of everything, and I'm sure everybody will take some of this away. To try and level that playing field a little bit, there's probably one prerequisite we should cover. There are people out there who think I talk in riddles, and I probably do. Lots of acronyms, lots of terminology, lots of tech talk. But today we're going to categorize some product into 2 camps. And everybody, when I mention this, it's going to be good if everybody has an idea of what it is the hell I'm on about. So we're going to talk about product that copes with what I would call 10 gigabits per second HDMI signals, and those that cope with up to 18 gigabits per second HDMI signals. Okay, that's probably not the way the market will talk about it. They will mention things like 4K versus full fat 4K. So we would call that full fat milk and semi-cream milk here in the UK. I don't know, I've made a guess. Is that half and half versus cream? Not sure. You guys in the States are going to have to clue me in there. Lots of people out there in the market will refer to it as 420 versus 444 4K. Technically incorrect, makes my blood boil a little bit, but it's a good way to sort of bring this to the masses in a way they understand. HDMI 1.4 versus HDMI 2.0. So people might say 60 hertz 4K versus 30 hertz 4K. It all kind of means the same thing. You have a line in the sand between product. The bandwidth, the amount of data that technology, that product can deal with will either be 10G or 18G. And we're going to talk about the product in those kind of 2 categories. So bear that in mind. I'll keep trying to remind people, but that's probably the one thing that hopefully of the mass amount of stuff that spouts out of me that we kind of need to grab before we start. Brilliant. Okay, here we go. So we'll start with HDBaseT. Okay, this is a military technology designed to get video, audio, power, various control signals across category network cabling up to 150 meters in length. Okay, this is designed to be thrown across an active battlefield in the rain and the sand. Okay, this thing has to be inherently reliable. Now, if you don't know what this thing is at all, there's loads of things you can take in on the HDBaseT organization's website. If you want to go really basic, if you want to go off into the land of incredibly detailed, then there's something that we can run for you called the HDBaseT Installer Expert Program, and that goes into some serious depth. So get in touch if that's something that's of interest. But we'll give you a brief look under the hood today, okay? And it's become, and it still is, pretty much one of the de facto technologies for moving signals around in a video distribution setup. And there are some really good reasons for that. It's all about convergence, though, with HDBaseT. It's all about getting all of these things together. So LAN, 10100 or gigabit network serving now. HDMI signals, like we said. SBDIF, things like optical audio, power. HDBaseT can carry up to 100 watts of power. Not many people do that. That means you can run a small television. And out here in the UK, we have a brand who do just that. They use a HDBaseT transmitting device to send power to a bathroom TV that's embedded in the wall. So there's now no power supply behind that television. We have things like RCA audio, RS232, RS485, and some of these things will carry USB as well. And it's all about grabbing all of that into one place and putting it on a single category network cable. Now, we're not going to go diving off into too much depth on the cable types and the cable constructions and infrastructure. We're going to try and keep that simple, but you can use standard Cat5 and Cat5e and Cat6 cable, and increasingly Cat6a to get 4K video, up to surround sound audio. We said that 100 watts of power, infrared, RS232, USB, and other things, point to point, in masses and masses of video distribution hardware. So switches, splitters, matrices, switches, I would say, you name it, there will be a product out there with HDBaseT built into it there. So, as we said, it's developed by a company called Valens Semiconductor about 13 years ago. And Valens designed a way to modulate a HDMI signal over that category cable. It's pretty much magic. We'll have a little look, but it is pretty much magic. Okay, and it uses a modulation type called PAM16 or PAM8, depends, but it's pulse amplitude modulation. Again, don't worry if that passes over the top of you. It's a very, very efficient method of transmitting lots of data on a cable that wasn't designed to do that. Okay, so it gets, we'll have a little look at a diagram that will explain that perhaps a little bit more effectively next. But what it means is that we can multiply up the amount of data that we can get down a category network cable that would only carry, say, 1 gigabit of network data, but now all of a sudden it can carry around 8 to 10 gigabits of HDMI data and control signals. So the technology is natively pixel perfect. Okay, it's utterly bit exact. Now that means that what you put in is what you get out of the other end. Caveats to that, in so much that when we start using compression techniques, that changes. We'll talk about those in a minute, but the core chipsets that are used in most product today that you'll find on the market, whatever you put in is whatever you get out. Now it's called latency free, it's called zero latency. It's such a small amount of latency that this technology adds that technically they can call it zero latency. So you just won't see it. That means it's not adding any delay to the signal delivery from your source device, like your CCT NVR, like your camera, like your Apple TV. That nothing's added in terms of its delivery of the image to the display. Okay, it's a method of distribution that allows for 4K, we said, all known HD formats to be delivered to distances where standard cable infrastructures like your HDMI cable just cannot go. And it allows for things like we said, control signals, IR, RS232, all to be set alongside it. And depending on the equipment that's being used and the HD chipsets, HDBaseT chipsets that they contain, things can go as far as 150 meters with 1080p video or 100 meters at 4K. Okay, and we can apply these compression methods that we'll talk about in a sec that can get us even further to get towards 18 gigabits per second signals. Now, there is the idea that HDBaseT devices are interoperable, and that's very much manufacturer dependent for a couple of reasons. But it's entirely, I guess, the easiest example to look at is a projector that will have a HDBaseT input. And you'll find that you should be able to buy a third-party HDBaseT transmitter, anyone, and transmit video over that category cable straight into that projector. And so you've got a closed ecosystem that means that interoperability is possible. And everything here is, there's EDID management built into some of the chipsets, HDCP compliance up to 2.3 now. So again, it's dealing with all of those things you'd expect to find in a HDMI device. The reason I say it's magic is because of the mess that this is. So don't panic at the sight of this, but there is no test later on. I'm not going to ask you how all of this works, but I just want to show you what the transmission on a HDBaseT or HDBaseT transmission on a cable looks like. Okay, we're using high frequency analog waves to hit different voltage levels. Now, try and get this. Each of those voltage levels, you got those shown on screen in the middle represents 4 bits of data. So 4 zeros or 4 ones or 3 zeros and a 1. But all we've done is actually send one piece of information to send 4 bits of data. So you can see immediately if one of our levels arrives, say level 15, like we said, level 15 arrives as a 1. Actually, what that means to the system is that that's 4 zeros. So we're multiplying up the amount of data that we can get across the cable. The magic is in the receiver, and you can see what it looks like after going down 100 meters of cable. It's just a garbled mess, and that is where the real magic happens in terms of the technology. It's taking that mess and rebuilding it into something that makes sense, and it's doing it stupendously fast with no latency on the fly. So make no mistake, it is magic, but it is stupendously reliable. Now, the important point with HDBaseT, one of them, is that it's a point-to-point technology. Okay, unintended. It's specified for a patch lead at each end, so what I would call a pinch point or a join. So we're going to have a longer segment of cable wall mounted in the middle. That's on that diagram in the middle at the bottom there for you. So you might have 90 meters of infrastructure of category 6 cable buried inside of a wall. And then you might have a 5 meter patch lead connected to that on either from a patch bay or from a wall socket or from a floor box at each end. And that's exactly what HDBaseT is specified to do. It is designed to go from one place to another. So you still have to build the supporting electronics that makes the HDBaseT device function as, say, a splitter or a matrix. So whilst the technology itself and the transmission is inherently reliable, it still does matter about the quality of the electronics that goes before it to get to the point of transmitting a signal across a cable. Okay, Valens make all of the HDBaseT chips. There isn't another manufacturer in the world who can make these. So everyone is paying the price that Valens charge, every manufacturer who uses these things. So it's all about the value add that you get around that. Are you getting the right backup? Are you getting the right pre-sale support? Is the rest of the product reliable? And that's where the differences really can be made by manufacturers, and that's really where Hall Technologies tries to push itself, is to make sure that those electronics that sit before these already inherently reliable chipsets is absolutely ultra reliable, top quality, and that we are giving you all the right backup. And that's where you have to fight against others. That's where the competition is. So, as we said, point to point, you're building something that goes in behind it. Now, it comes in a few flavors, each chipset with slightly different specifications. Again, no test at the end. I'm not going to get at anybody who doesn't remember any of this. But you're going to have, let's pick out a few that make sense to people. You have something called, you have the specifications. You have Spec 1 product, Spec 2 product, and Spec 3. Now, in Spec 1 of HDBaseT, the original devices, you have 2 chipsets. You have the VS010 and the VS100 that are most commonly used in the AV product that you find out there today. Now, the 010, I would imagine you guys are going to know as the HDBaseT Lite product or a 3-play product. But it's 4K to 40 meters and it's 1080p to 70 meters. That, I would say, is on a Cat6 cable, and that will carry things like IR along with it, and you can carry the power along, so you can send power from the transmission point to the receiver. The VS100 is something you guys might know as HDBaseT Pro or as 5-play. So it's 4K 70 meters, 1080p to 100 meters on your Cat6. And then you've got the addition of 10100 Ethernet available at the same time. After that, you can move into the HDBaseT Spec 2. Okay, now the most common chipsets here are going to be the VS, I think it's going to be VS2000. And this is where we move into things like 4K at 100 meters, and then it add in the feature to have 1080p go to 150 meters in something called long reach mode. Your 10100 Ethernet's all there, and then there's also a variant of that chipset that comes with USB, and that's obviously a massive key for people in the Pro AV and the commercial space, and it's why you're going to find, I want to say it's 2030, but I'm probably wrong, but that's the chipset that you're going to find in most product from Hall Technologies, because we want that USB functionality. Then right now, we've got Spec 3 product, which is very recent, something that's come to market in the last 12 months. in my experience. But we're now moving up through from Spec 1 and Spec 2. They are 10 gigabits per second products. Remember that I said we're breaking product down into two sets. This is the lesser HDMI bandwidth, the lesser spec 4K devices, and then the Spec 3 product will bring you up to that full fat 4K natively. So a totally untouched signal. The difference with that is that you're going to be looking at a different cable infrastructure to get to your full distances. But we'll have a look at that in a sec anyway. But those are your three main groups. You've got Spec 1, Spec 2, and Spec 3. And based on the features inside a product, you can make a reasonable assumption as to which chipset's in use. Now, when it comes to Spec 1 and Spec 2 product, as we dive a little deeper, we said that there's both. Let's go with they're both that lesser 4K variant device, that 10 gigabits per second HDMI technology. And we need to use a little bit of wizardry to get up to that full fat 4K 18 gigabits per second HDMI support. Now, there are two main ways of doing this, something called CSC, or color space conversion. And the other thing we can do is something called DSC, and that's display stream compression. So CSC is something you're going to find quite commonly given a different name, given a proprietary technology name. People are going to turn around and tell you that it's their method of doing it. There are only two chipsets available on the market that I was aware of that performs this function for HDBaseT, and everybody's using the same chipsets. So you might see things out there like AVLC, let's think TPC. People try and give it a brand name when we're all doing the same thing, and the end results are the same. But it's taking color data out. Okay, so it can do reductions of 10-bit color data. So your choice of colors can be reduced within the signal from what we call 10-bit to 8-bit. So the number of colors that you can make a selection from is shrunk. Or it can reduce what we call the chroma subsample, and we are not going into the depths of that today, don't worry. So that's your 444, and it can reduce that to 420. And I don't care what anybody says. I'll get controversial. The data is not replaced. Okay, so it's a pseudo method. It doesn't. That data's gone. Okay, the metadata is for the signal is replaced by the receiver, and that means that when your customers press the info button on their television, they can see, or on their display or monitor, whichever one we're talking. I'll get shot for that. It's not a television. It's a monitor or a display. Whatever anybody's doing with that, they will be able to press that info button and they will see that it's coming through as an 18 gigabits per second, a full fat 4K signal perhaps, when actually it's not. What they're looking at on screen is the lesser version. So CSC works to give us the ability to plug in devices to HDBaseT product and it function and it give out its maximum capable resolution and all the color and everything. But what you get out the other end is not necessarily what you put in anymore. And it's not something I think that most of the AV world goes out there to tell people. And you'll find that with us. I think there's that degree of honesty and transparency where we are going to just give you the truth of the matter. DSC is slightly different. Okay, this is a more expensive method. This is something that is only usable on Spec 2 HDBaseT product and beyond, and it's the official HDBaseT solution for getting 18 gigabits per second signals over the lesser bandwidth 10 gigabits per second link that you have with HDBaseT. Mathematically, you got less data being removed. It's color and contrast info. The results are visually similar, but mathematically better. Sounds a bit of an odd one, doesn't it? These two technologies are not at war with each other in my head. One is not better than the other. They both have their pros and cons. Okay, the CSC methods are less expensive and they can be used on the lesser expensive HDBaseT chipsets, so it's far more prevalent in the market. Okay, and either of these solutions is perfectly good for most general viewing applications, and I have not had anybody complain about the image quality. And I know compression is a bad word and people are quite negative towards it, but this is a great solution to make older HDBaseT product that has a limitation bring you up to full 4K territory. Okay, in Pro AV and commercial, 18 gigabits per second, that full fat 4K requirement isn't very common. It's not a very common request, but it is increasing. So you're going to see a lot more product like this emerge from Pro AV manufacturers over the coming months, I'm sure. And in 2 or 3 years' time, I'm sure it's just going to absolutely be a standard. To give you an example of a Spec 1 product, something for our HBX kit, but you're looking at HDMI, infrared, RS232, 10100, Ethernet, all carried over the same cable. Okay, this is a Spec 1 HDBaseT 5-play VS100 product, because you can see that LAN feature there. So you're doing 100 meters of 4K, 100 meters of 4K on a piece of Cat6 cable. So that's an example of where things begin. When you're moving towards the Spec 2 product, you can tell that the defining features over Spec 1, without going too technically deep, we've got long range mode, so we can send 1080p 150 meters, and we've got USB native to the chipset as options. There's audio return channel if any of you guys are using that, but I doubt it. That's a much more residential feature. The Pro AV market, as we said, is calling for USB more often than not. So you should find products like our UH18 that we've got on screen there with the USB chipset selected for use as standard. Spec 3 is a little different. This is our first HDBaseT Spec 3 product, and one of the first products to market full stop to make use of the chipset. And this is our expansion card for our MC200 product, if no one's dug into that. And it's definitely worth a look to understand how this helps to take a HDMI device that has 2 HDMI outputs and then add that long distance signal transmission capability. So Spec 3 products, they're just creeping into the pro market. Okay, we said that requirement for full fat 4K, full HDMI 2.0 signals was growing. And this is the type of product that you're going to start to see that can give you that natively without any trickery. Okay, the HDBaseT Valen's response to the limitations of the Spec 1 and Spec 2 product, requiring that kind of compression or conversion sprinkle that we talked about, is this. Okay, so you are getting absolutely uncompressed, untouched, full fat 4K over that cable now. No magic, no trickery, no messing around. It's bit for bit exact, the same picture at full fat 4K going in as it comes out. So we're back to replacing literally a HDMI lead with no mucking around. So it's we're emulating a HDMI cable. So yeah, absolutely brilliant. The thing I would mention with this is that you are talking about needing Cat6A cable to reach the longer distances. Cat6 is fine, you're going to get some distance out of that, but it's another step on in terms of infrastructure complexity, another step on in terms of how you've got to terminate that in the field and educating people in doing that. So little things to go with it, but the end result is that you're getting full fat 4K without any kind of tampering. Plenty of applications for HDBaseT technology. Before we look at the specific ones where it wins out, first and foremost, yes, fine, residential AV distribution solutions are there. Okay, for getting various source signals around a property to multiple zones. But then there's that host of commercial scenarios, corporate applications, meeting rooms, something where, as I said, we sit very strongly. That's a HDBaseT realm. We got things like education spaces, retail, and then maybe some of those smaller sports bar areas. They are all going to be quite HDBaseT prevalent applications. So why would you use the technology in general? Okay, pros, we have that bit for bit zero latency. Okay, we've got absolutely proven reliability with this product now for over a decade. Its pricing, when it comes to the smaller setups, is very strong. So if you are moving, say, one source to 4 displays, or maybe 4 sources to 4 displays, then this is absolutely the right space for that technology, and our alternatives are going to look more expensive. Okay, we can get to that 18 gigabits per second, that full fat 4K support now as well, without any kind of compression or conversion if we want to. The cons with HDBaseT, or those downsides potentially, are that it's difficult to scale sometimes. So if you are on geographically, what I would call a geographically very large project, you've got 100 meters or 150 meters of copper that you can make your transmission on. There's no way to kind of get around that without maybe daisy chaining products together. So you are limited in that regard. If you do look at HDBaseT solutions that work on fiber cabling, then they are, as we said, point to point. Okay, they are not going to pass through any kind of network hardware. This is it's packet-based transmission, kind of like AV over IP, but it's not the same, so it doesn't move. And the number of times in my 15, 16 years of supporting this product, I have had people try to pass this through a network switch and wonder why it doesn't work. It's not going to. Different transmission with a similar structure. But it's expensive to scale if you get stuck at a limit. So if you have the devices typically come in 4x4s, 8x8s, 16x16s, 32s by 32, 64 by 64, but they are seriously expensive pieces of kit. If they're in a fixed format, you might be buying inputs and outputs that you are not going to use. And if they are modular, you're still looking at slots of 4, maybe slots of 8, but you are still going to get stuck at the limit of a chassis. Or if someone's going to buy the biggest chassis they possibly can, they're spending money potentially needlessly. So it can be an expensive thing. You've got to take out that whole central unit if you want to go from 4 displays to maybe 5, and you've got to look at changing it for something else entirely. So it's one of those that can be expensive to scale if you get to that point. The other thing to mention is the amount of data, the amount of bandwidth, the amount of stuff we are pushing down that cable. With HDBaseT, it's quite high. Okay, it is a very clever and efficient use of the cable, but it is a very high bandwidth, and that can lead to infrastructure issues coming out that perhaps wouldn't with other solutions. It does mean that you've got to be able to go in and get your infrastructure correct absolutely as much as you possibly can, looking at testing your infrastructure to know this is going to work. And we have a bit of a note on testing later. So it's using the cable in a manner that might bring out issues versus other types of technology. And then we mentioned the interoperability. And is it genuinely there? Is it really there? And if you're looking at a HDBaseT transmitter from Hall Technologies, and you're saying I'd like to use a HDBaseT receiver from someone else, there are a few factors that may mean that those devices won't work together at all, or that if they do, you'll get video and audio, but you might not get the other types of signals because of the way things are implemented. And there are some scenarios, if you do have, say, a projector, that some manufacturers, not ourselves, could be sending unnegotiated power from their transmitters, and that's just going to go straight into your projector and blow that HDBaseT chip up. It's gone. So the interoperability, you have to be careful with it. It is there, but we live in the land of consumerism. Hall Technologies would love you to use both their transmitters and receivers together, and we wouldn't necessarily build it to work with everybody's. So just bear that in mind. So that's our kind of introduction to the HDBaseT side of things. Hopefully that's all made sense. It looks like I need to get a move on. We'll talk AV over IP. Okay, logos for AV over IP are quite tricky to come by. So thank you very much to one of the clever brands on the internet who.
Hey, Dan,
go on.
Hey, Dan, before you move over to AV over IP, could you talk about EMI a little bit, maybe from the last slide, so that when we transition over to AV over IP, that it's not as prevalent?
Yeah, no, absolutely. Absolutely, and it's one of the pros and cons and the benefits that we'll touch on in a little bit, and it goes with that bandwidth on the cable.
Perfect. Okay, cool.
Absolutely, infrastructure is definitely key to both of the technologies, and there are reasons why it's more key in the HDBaseT realm. EMI, electromagnetic interference, is something that can come in and affect a HDBaseT signal. It's not common if things are done properly. Let me give you a couple of examples. I did a oil traders on Piccadilly Circus where they bundled all of their cabling. It's in very beautiful combed rows into a false floor, and they were experiencing picture dropout consistently. And it's to do with the fact that the cabling wasn't installed to spec, in that they'd combed it from point of source. So everything's in beautiful straight lines. You're actually not supposed to comb cable infrastructure until you hit 20 meters. And it meant the strongest point for signals, that point of transmission, they're all lined up, and you're actually getting crosstalk between the cables. So because it's that very high frequency, very high bandwidth transmission, then that kind of thing can take place. With Spec 1 product of HDBaseT, if you take a walkie-talkie and you walkie-talkie. Oh, come on. It's not the 1990s anymore, is it? Let's think like a radio. If you take some,
there you go.
Okay, thank you. Let's use something modern. And you bring that towards a HDBaseT device, then there's no checking between the transmitter and the receiver that the data is going from one end to the other. The transmitter's not sending, say, oh, here you go, and the receiver's not going, yeah, I got that, thanks very much, give me the next one. That isn't happening. So that means that signal can actually be interrupted and broken up. With Spec 2 product, there is an amount of what we call checksums, an amount of checking going on to make sure that the signal is getting from one end to the other. So again, that's reduced. It's not something I've seen a massive amount of. What we see more of when it comes to infrastructure is guys using testers that we'll touch on in a little bit for IP at 1 gigabits per second of data. And then they go, well, it's not working for HDBaseT. And it's like, well, yeah, can the cable carry 10 gigabits of data? Have you used a HDBaseT tester? No, it's a different type of transmission. So, and again, we'll touch on that in a little while, but you have to just, with infrastructure, it's all about making sure that it's as good as it possibly can be. Daft things like when you have issues where you're not reaching your distances, people use patch leads with stranded copper cores. Half the time we can just change those to solid core patch leads, and it will improve that cable run enough to give you a result. And the guys here in support are all voiced in how to help you if you hit that point. But hopefully I can give you a few tips in a little bit as to how to not get to that stage. All good? Thumbs up, Josh?
Yes, sir. Thank you very much.
No worries. So we'll talk AV over IP, and I'll get moving because we haven't got long left. AV over IP simply describes the delivery of HDMI content and other like control signals over a LAN infrastructure. Okay, 4K 60 video, HD audio, control signals. We are talking about using absolutely standard network hardware off the shelf. Okay, they have to have certain specs, but it's TCP/IP data. Okay, it's something that you will do your internet browsing on, do your mobile banking on, and it runs the world. So the way this moves data around is dirt reliable. It offers a flexible solution, as I say, that can get you things into places that HDBaseT can't. And once you've got your head around it and learned the basics, then it's actually a relatively simple thing to integrate. It's so versatile. Okay, it's quickly becoming an industry standard for installations in both commercial and residential, and it's allowing you to expand systems on a port-by-port basis. Your system size isn't limited anymore by the number of ins and outs on a fixed device. We're actually just talking about the number of ports that are available on your network switch. I should point out that most of these systems, if not all, are hardwired. Okay, due to the amount of data that we're sending over the network, you can't get things wirelessly or onto a wide area network. That's a different thing. What we're talking about here is taking signals into a box, passing them through a network and getting them out of a box at the other end, where you can pick up, say, a stream on your phone or into a player. That's something I would call IPTV, whereas this is something different. In order to maintain HDCP copy protection and be legal, we are talking about a box-to-box scenario. And if these things weren't as simple to put in as HDBaseT product, no one would be using them. So yeah, absolutely brilliant. Whilst you can get it through existing networks, I should also make that point, you need to know what you're doing when it comes to that networking. The power of the platforms are immense, but we stick a fork in the sand and say you've got to have this on its own switch. You've got to have it running on its own network, just to keep things simple, and it doesn't frighten people off. But there are some very, very clever networking people out there who can work with us to understand what it is that they need in order to get to, say, through an existing network. So it can be done. Like we said, infrastructures can be created, rearranged. Signal deliveries can be point to point, point to multi-point, multi-point to multi-point. You know, there are virtually no distance limitations here. Okay, now this can make it convenient and cost-effective to connect HDMI signals from things like across a home or large-scale commercial or industrial premises. Okay, because you can take two switches and join them together to network points, to network nodes, to network switches, and connect them via what we call a fiber cable with the right fiber modules. That could be 100 kilometers. Okay, and I've been and spent time at a sporting event in Japan, not allowed to mention by name, where the furthest run away was 830 kilometers for the video over IP system that we oversaw. So you can go massive distances, okay? And because it uses less bandwidth than HDBaseT on a cable, you can run AV over IP on Cat5e, okay? So a retrofit is far more likely. You know, you can utilize existing network infrastructure that's already there, using additional, putting in additional bits only as required. And it eliminates that excessive need for new cabling infrastructure, where if you've got Cat5e, HDBaseT is at quite reduced distances. So it can make for a very cost-effective and highly stable environment that, say, is easily configured, easily controlled. And I would say this kind of technology is expected to dominate installations involving more than a handful of sources and screens as we move forward. And what we've been seeing is those matrix switch, those HDBaseT device, and certainly the 32 by 32, the 16 by 16, those things continue to slow down. So typically from an AV over IP based system, you can grab the features that you've got on screen there, amongst others, other things you can typically expect. So compression, we said, was a bad word. There is a lot of compression going on here with AV over IP, but it's good compression. There is such a thing as bad compression. The example I always like to give is that if anybody's ever watched a 4K Blu-ray, or if you guys have sat at home and you've watched a 4K HDR a piece of television from Amazon or from Apple TV, and you've looked at that picture and thought, that is great, then you've looked at something that is massively, massively compressed, and you've been impressed by it. So yes, there's a lot of compression going on here, but it's not bad compression. Latencies can vary on different platforms, and we'll very quickly cover the different common platforms that are out there. They go from 0 to 100 milliseconds, depending on the technology that is inside your chosen system. So some are good for live events, some are not. Signals distributed vary over, again, with system, 10100 gigabit, 10 gigabit Ethernet networking technology, depending on the platform that you choose. So there's something for everybody again there. And we're carrying audio, video control, and most, if not all, of those devices out there now can be powered from the switch. So we're not putting those wall-wart DC power supplies behind every device. And like we said, you can go 100 meters on copper, because those are the limits of IP in spec of the TCP/IP data, and then we can go even further if we go on to things like optical fibers. Video wall features tend to come built into these devices. Can't tell you why that happened, but over the years, you're going to have video wall processing that is already there. So rather than you having to buy video wall panels or panels with video wall processing built in, you can do that actually from your AV over IP platform in most cases. Again, because that video processing is there, you're going to find scalers built into most of these, if not all of these devices, to allow you to mix and match specifications of screen and get an image everywhere. And all of them have that those tools that you need when you're doing video distribution in terms of EDID management. Not going to go into depth of what, and then HDCP compliance as well. So we're not breaking any rules we shouldn't. Excuse me if I'm speeding up. There are lots of flavors of video over IP technology out there, AV over IP, and it can be reasonably broken down into 3 categories, in my humble opinion, with a couple of outliers. So we're just going to give you a nice, quick overview of the market. Similar to the chipset offerings of HDBaseT, okay, you can achieve different things with different AV over IP chipset families. First up, I like to call them the H.265 systems. Okay, these are typically 1080p only. They are longer latency systems, okay, because you are taking your images and you are compressing them a lot further. So they are computationally more difficult, the word, and that means that it takes longer to get that image shrunk down into that smaller amount of bandwidth, that smaller number of ones and zeros. And typically the chipset offerings at this level of product are the least expensive ones out there as well. Second up are the H.264 systems that now step up into gigabit Ethernet networks. And this is a market that's almost exclusively used up to exclusively set up to use chipsets from a company called ASpeed. Here at Hall Technologies, we like to make sure that the respected partners we use in the world of electronics, that we let you know who they are, because it brings credibility to what we're doing. But a lot of the guys out there will hide who they're using, and again, they'll tell you that they're doing something entirely of their own making, when it is probably just the same thing in the core of it. Last up, the SDVoE 10 gigabit Ethernet systems. Okay, so you're into a whole new level of networking required with these, but what you get for that is a system that gives you zero latency and the ultimate in video over IP picture quality. Okay, so there are payoffs and trade-offs to make between the two. Cool. These are just some examples of some of the brands out there that have a platform based on the AVoIP chipset. And just like the land of HDBaseT, you have to differentiate yourself with the features that you make available from the chipset, what you bolt on in the electronics that supports it, how it's controlled, how it sets up, and then how we support you and how we help you in designing and implementing these systems on site. And that's where we try and put ourselves at the absolute top of the tree. Some of the brands out there, similarly, are using that little sprinkle of CSC magic that we talked about in order to get full fat 4K signals into this AVoIP platform. But ultimately, that data being removed, the result's just the same. The picture is just the same as any of the other platforms. So, but it gives you an example of a lot of the brands out there that are making use of the same core chipset device. The next system we mentioned was the SDVoE platform. Okay, this is actually a chipset called the Blue River NT Plus from a company called, or was Aptivision, now Semtech. And SDVoE can be likened to Valens, the creators of HDBaseT. There was only one manufacturer for these chipsets, but I believe there's a couple more now. But multitude of brands will build onto these. But the SDVoE are far more prevalent in how they advertise on product, and people like to make them aware that they are using this technology. And there's a lot more interoperability here with SDVoE devices than there would be with any of the AVoIP platforms. So you can get things that work together when you're using SDVoE hardware. But it's a 10 gigabit Ethernet network. Okay, so it's a step up from the 1 gigabit Ethernet networking that we've had for the other platforms, and that in itself presents a challenge. Okay, building a true 10 gigabit Ethernet network, particularly to spec, is much harder, and the switching's more expensive. And if you need to stack switches to go connect things through larger fiber connections, longer distances, then the uplink speed between those two switches, how much data you can pass between those two, becomes massive in order to accommodate the amount of things you're pushing around. So it can be self-limiting in terms of system size, physically, and in terms of numbers of inputs and outputs. And you've got to be able to go in with a 10 gigabit Ethernet networking tester as well. You've got to be able to rent one, you've got to be able to buy one and use one to show that the cable infrastructure you're connecting to is absolutely functional. And that's much more expensive to do. The key for the future of this technology is the arrival of what we call the ASIC, so a dedicated piece of electronics that does this job. We've moved away from something that they buy off the shelf and turn it into an SDVoE device to something that is absolutely dedicated to do it. So you're going to start to see the cost of some of these bits of hardware come down, and you're also going to start to see, watch this space for our variant. This is absolutely something that Hall Technologies is all over, and you'll see something from us in the future, I'm sure. So it still represents a much more expensive solution potentially than your ASpeed in general or your H.265, but what you get is things like image quality, we get multi-view, and for example, the medical industry love this type of product because there is that zero latency and there's that absolute top of the tree pitch quality. To give you your two outliers, because it's worth going over, outside of all of those three things, you have Atlona and Crestron. Crestron have the NVX system, which is an Intopix codec-based system. Brilliant bit of kit. No one's here to deny that. It's just not in stock for a long time. But it's 1 gigabit Ethernet networking. It's 18 gigabits per second, full fat 4K signals, great image quality. We're not here to put anybody down. It just needs to be used with a Crestron system, unless someone's got very clever and managed to integrate it with another third party. It is expensive. It runs hot. Some of the older devices use fans. And to be honest with you, some of the time it's not PoE, it requires its own external power supply. Some of that might change since I created all of this, but there are definite cons to that platform. So again, if someone wants to update me and correct me, go for it. Atlona is using a Xilinx based chipset. So we're not using ASpeed, we're using something from a company called Xilinx and using it for their OmniStream platforms. Again, this thing, great, but it's massive amounts of money. And the way it compresses an image is something that was built for the BBC to use for 4K television transmissions. But these things, you're going to have to go out and sell a kidney or a lung to get these things in. And sometimes the advantages that these two brands will give you are just not worth it or not required, or you can actually achieve what you need to and want to with the lesser brand. Now, to that end, the unicorn, as we like to call it, what else is coming for AV over IP? And the unicorn, the thing that everyone is chasing after, that pot of gold at the end of the rainbow, is a 1 gigabit Ethernet networking AV over IP product that does full fat 4K, and it does it at a value price point. Okay, we might have something out there that does that already in tune of NBX or Atlona, but it's the cost of those things. It's how expensive they are. And we have something coming from ASpeed, new chipset coming to market, that is something that we're working with and working on having that gives us this unicorn. So keep your eyes on, and hopefully you'll see something that comes from us that will get you to all of the things you want and need at the right price point for AV over IP. So it's going to get even stronger. Typical uses, quite similar. Again, we're talking about information systems. We're talking about sports bars, maybe with those video walls integrated like you can see on screen now. We're talking about digital signage. We're talking about large residential, we're talking about control rooms. All of these places, mission critical, you could call them, but every one of these you can be considered mission critical to the user, but somewhere where these things are they've got to always keep going, 365 days a year, always giving you that picture. And yeah, so a bit more of a commercial skew. So why would you use video over IP in general? We said pros, transmission type is inherently reliable. Everything we do in this world on the internet in terms of networking is on IP, so we know it works. You've probably got a 1 gigabit Ethernet network tester already if you're an integrator, so you can actually use that tester to test that this is going to work on the cable much more easily than you can test a piece of infrastructure for HDBaseT. And because it's that less bandwidth, less amounts of information going across the cable, it's more likely to work where HDBaseT won't. So you get that retrofit safety. Okay, we're going to get, you get away from that bit of fear. That old bit of Cat5 is going to work for 100 meters of AV over IP if you test it out to the right amount of bandwidth. It's much less expensive for larger systems than it is for a HDBaseT system when you go to maybe, as we said, over that handful of sources and screens. So we said we can go to huge numbers of ins and outs, and as well as be very geographically large in your deployment far more easily than you can with a HDBaseT system. Cons, we have to talk video quality. Okay, there is a reduced video quality on some of these systems depending on the way in which they shrink your image. It's called visually lossless because side by side you shouldn't be able to tell the difference. But if you start to blow some of these things up to massive scale, then you might begin to see the differences. So we're talking large LED format displays and that kind of thing. So there is a video quality consideration to make. To go to full fat 4K at the moment, as we said, is expensive. And if you're trying to do it in a very small setup, it's going to also look expensive versus the HDBaseT product. Not long to go, I promise. War. Okay, how many of you sung that in your head? I did have a poll ready, but they told me to take it out because apparently it wasn't very good. But there we go. So first thing we all need to get our heads past is the idea that these technologies are at war. Okay, some manufacturers are going to let you believe there is a single solution and that the technologies are at war with each other for market share, that one is better than the other. But war, what is it good for? That's the only joke I put in. Absolutely nothing. Okay, that's completely right. It's good for nothing. War is a barrier to you guys providing the correct solution. Okay, and there are integrators out there who only use one technology on every project for perhaps driven for a variety of reasons. But the idea that one side of any fight between these technologies is totally correct right now at this moment in time is madness to me. Okay, manufacturers typically have product with multiple technologies across their range for a reason. We have HDBaseT product and we have AV over IP product, all technologies for a reason. Now, I realize that, there are other factors at play. The technology could be great. If something else around it falls down, it wasn't the right solution, but there's no point in having brilliant product, no support or backup. Okay, it counts against it. So there might be an oversimplification to say that the technologies aren't at war, but the point is no one video distribution technology has all the right answers for every project. If you stick to a single solution, you cannot be, in my humble opinion, always installing the best solution, which is controversial perhaps. And we're here to help you choose the right one. We're not going to shoehorn anything in for you that doesn't fit properly. So just very briefly go over then the benefits of HDBaseT that we mentioned. Absolutely picture perfect up to the standard 4K, the semi-skimmed 4K, and then on the newer chipsets all the way up to the full fat 4K is absolutely native as well if you want to go that far. That latency free, so for time critical installations, absolutely spot on. You have longer distances. You know, the UH18 is pushing things up to 150 meters, whereas AVoIP is only going to go down that 100 meter unless we move to fiber. There are things like other things being added, like the use of 10100 or gigabit Ethernet on the same cable you're moving the video over is perhaps easier to achieve in some of the HDBaseT scenarios. And for those that are cost conscious, HDBaseT is still far more cost effective at the lesser end. So you're going to use it in point-to-point scenarios more often than not. Got our UH18 on screen there for in a medical situation, medical scenario. You're going to use that potentially in meeting spaces with something like our Discovery. It's going to be more capable and less expensive than an AVoIP solution to do it that way. HDBaseT definitely wins out in the point-to-point scenarios. There are always outliers to that. Okay, AVoIP can save your bacon if you really need it to on a point-to-point scenario, but HDBaseT is where you want to go first. Where distance requirements aren't quite as long as an AVoIP solution, perhaps, and you've got that point-to-point cable, then things like meeting rooms using a HDBaseT splitter. We want to get one source, one picture to multiple displays, easy peasy in HDBaseT in that kind of space. You know, more sort of multifunction meeting room spaces where the room can have dividers put into it, so we've got chances for multiple configurations, multiple displays, again in that small size, 4 sources in, 4 input plates at the wall, and to maybe to 4 displays. Again, HDBaseT is going to seem like a much better solution to go for. You're also going to be talking about the unified communication, smaller meeting room spaces. So things like our Apollo TRK1. This makes use of HDBaseT technology point-to-point in a smaller space, because building something in AVoIP wouldn't make sense in that product. And similarly with things like our Odyssey, that tabletop conference speaker microphone has a HDBaseT out fairly uniquely, will sit on that table, and that you only need a single cable then to your display in that meeting space, and you can transmit things like USB cameras back across it. But it means a short cable plug-in to make sure to get everything happening in a video conferencing or a meeting room space. It wouldn't make sense to do that in an AVoIP technology. Live and broadcast, due to lower latency in HDBaseT, perhaps barring some of the SDVoE solutions, HDBaseT will fit into live and broadcast much better. Okay, and there are increasing use of network technologies like Dante, means that AVoIP is going into a lot of more of these scenarios to keep it all within a network. But you've got, as I say, got to watch the latency in the solution. Gaming would be the last thing I mention. HDBaseT have been running workshops on using the technology with VR for years. It's that low latency feature and that absolutely bit exact image that gets you there. There's a gentleman called John Marshall, who I've seen some things from Valens, who talks about this. And then similarly, remotely locating PCs at esports events away from the keyboard and mouse, away from the screen. So those are all good applications for HDBaseT technology. AVoIP, we said, visually lossless with varying compression techniques. Because we're using less bandwidth on the cable, AVoIP far similar to implement into systems with existing cabling. Therefore, it doesn't require new cables infrastructure to go in. You're going to be on the larger systems. You're going to be looking at far more cost effective, perhaps 4x4, perhaps 8x8. It's a fully modular, these things. They're individual boxes. You can change, add inputs, remove inputs, outputs. Far easier to do that than with HDBaseT equipment that's traditionally sold on a fixed I/O infrastructure. And we said things like scaling and video walls, that video processing that's built into them. Okay, and the obvious angle for this is going to be things like commercial installations with a physical size that's big, a huge number of inputs and outputs. Okay, and my work over in Japan saw us with 43 sporting venues, one of them 832 kilometers away from that central location, all on the same network. I think we ended up with over 500 inputs and over 1,700 outputs. And there is just not a practical way to produce that in the land of HDBaseT. And we said things like maybe perhaps gyms, that 1080p requirement. If you only need 1080p, you just want to get MTV, if that still exists. I think we're back in the 1990s again. If you just want to get that round the gym, you know, we don't need full fat 4K image quality in those spaces, perhaps. Then you're going to find 1080p AV over IP solutions that will do that for you. And we said things like control rooms where you need to change the video wall layout on the fly from a third-party control system. And when there's an event happening, I mean, I've done work with Rescue Global where it's mission critical, right? We've had an alarm. We need all of that up on screen right now. And you can do all of that on the fly with I think, nearly all of your AV over IP platforms that are out there. Cool. So we said AV over IP for the retrofit. Okay. Yeah, usually AV over IP. When the infrastructure has a question mark over it, okay, people default to a video over IP solution because of its lower bandwidth usage on the cable. Things end up going in because guys don't test. They don't do anything to remove their fear. They plug and pray. Okay, never ever plug and pray. You have to test the cable. And that's why I say that video over IP is great for a retrofit, but it might not be the right solution if you haven't tested that cable to actually know. So that note on testing, you can test for both HDBaseT and AV over IP signal types on your cable infrastructure. I know we're over time. I am flying, I promise. When you plug on something onto someone else's infrastructure for video distribution, now, whether you get signed legal documentation or not, you've kind of taken ownership of that infrastructure in the client's mind, even if it's just a little bit. Okay, I've never had an electrician come to my home to look at half-finished work and then connect onto it. Okay, they don't trust it because then they're the ones who are going to test it all and have a system attached to it at the end. They're going to restart. They're going to start from scratch again. Okay, that's life and death, but the point stands. Get testing your infrastructure, because if you know what you're connecting your own kit onto, then you can be confident it's going to work. And if it's not going to function and it's a service you can charge for, the test, and it's a service you can charge for to correct that infrastructure, you could find that the infrastructure is not up to scratch after you've plugged kit onto it. And because in the client's mind, you've taken ownership, it becomes your problem. You know, you're the one who gets the image to the display. You are the visible part of that solution. That cable's in the wall. It went in 10 years ago. It's not my problem anymore. It's yours. So don't leave yourself open to profit loss through issues that could have been there long before you arrived. You know, remove that fear. Get these things tested. So the M Solutions HDBaseT tester is a more expensive device. That is a negative for HDBaseT. These things are great though, and they're probably one of only two I'm aware of on the market that will do that work for you. But you're more likely to have a 1 gigabit Ethernet, plus 1 GBS, 1 gigabit Ethernet network tester, a qualifier. Again, I'm not going to go into the different types of testing, but if you've got something like that Fluke Cable IQ there, and you run that on a cable infrastructure and it comes back with a big tick, you're good for a 1 gigabit Ethernet AV over IP system because you tested for exactly the same amount of type of transmission. So that's a big plus for AV over IP. So taking all of that into account, kind of bringing all that together, what are the best solutions that we're seeing at the moment though with Hall Technologies? And to be honest with you, they're hybrids. You know, people are letting go of the total centralized option for a number of reasons. They are letting go of the idea of sticking all to a single technology for one solution. They are working with the pros and cons of each type of technology to get to the best result for their customer. And the greatest example of that, where you're going to use a hybrid, okay, something like a campus. And I've done this, okay, we are going to move signals between buildings using AV over IP. But then within each of the buildings, you might find HD distribution in the local parts. You might even get down to small meeting rooms where they use HDMI only. So you've got 3 different types of signal distribution, maybe even USB-C cabling, all fitting into the same space to give the customer the best solution. If it was all AV over IP, would it be the best solution? Potentially. If it was all HDBaseT, can it be achieved? Probably technically not. So absolutely, the hybrids are the way to go when you're on larger deployments like that to build your client the best solution. Now, I did have one more note. Oh, we've run through that quick. One more thing. Again, does that must translate? Come on, it's an American television show, don't you? So we are here to help. We are here to take down barriers. We are here to remove the barriers for you to get to the best solution, to choose the best technology. And you guys are clearly open to learning because you're here. Okay, so take away the fear of learning. Take away that fear of learning. We are here to help you create the best solutions, but do get into those pieces of education. Ken's written some brilliant white papers. We've been involved in some panel discussions. There's a lot of material out there to help you learn which way to go for your scenarios. And then there's Josh. You can always call him out and say, what am I supposed to do? But don't fear it. You know, make time to test, like we said, make time to learn. I know time, let us help you save time. Okay, it's precious. But if you don't explore just because you're too busy, are you giving your client the best solution? That's possibly controversial, but are you? Now, make time to make sure you're doing the right thing. It's professional development. Past experiences, don't get stuck on the technology because you had a bad experience once with one. If things move on, they get better. Those first HDBaseT devices I played with and sold in the UK, say 13, 14 years ago, were dire. But now things are just so much better. So if you've had a bad time with the technology, maybe it wasn't the technology, maybe it was the service you received around the product. Maybe you didn't get the help you needed. Let us help you get the confidence back in both of those technologies, so you're going to get the best solution out there. Now, loyalty. Now, I know this is hard, and the sales team will hate me, but don't just buy from Dave because it's Dave. We all know Dave is a great guy. He might take you on a ski trip. Okay, but he's only got HDBaseT product. He doesn't have any AV over IP. Well, that's no good. Make sure you are speaking to all the right people to get the best solution you possibly can. Okay, and trust. You know, we want to build trust with you. It might be another controversial point, but if you're speaking to a distributor about our product, then or about anybody's product, make sure you get in touch with the manufacturer or get the guys to channel you through. And I know that our reps out there, and I know that our sales team out there, we are one big happy team and a family that do just this. They're not doing this kind of thing day in, day out all the time. Okay, I have to know one thing. I have to know one technology. But there are guys out there that have to know lighting, they have to know sound, they have to know everything, and they'll know all of them in a depth, but then we'll know that in a greater depth, and it's about access. So we're here to back them up, or you can get in touch with us direct and ask us those questions. Okay, but make sure that you're just not sitting there saying, well, I've been doing this for 20 odd years, I know what I'm doing. You know, ask the questions of us. There's no such thing as a stupid question. So cool, let us help you to get to the best solutions for your clients using the best technology for the job. Cool. I have flown through that last little bit like a madman. Any questions from anybody? I don't know how we're going to do this. We're going to do Josh, Roy, have you got anything in Q&A? Does anybody want to raise their hand?
We have, but we've handled it, and I think you did a fantastic job, man. I don't think we have any questions unless anybody is feverishly typing right now at this particular moment.
Good.
To get those in. But, yeah, very well done, man. Thank you so much for putting this together. This was very good. I hope everybody learned something, took away something from this. We hope to be doing a few more of these, kind of keeping them a little bit more agnostic like this. But Dan, thanks again for putting this together. It was really, really well put together. Thanks, man.
No worries. I would say, like I said, there's no such thing as a stupid question. You get to that point where people don't want to ask those questions here. Don't be afraid. I've got one there from Christopher Edwards. I can see say, do you have a system design team? Well, we do. That's kind of all of us. So that's Josh, that's myself, that's Ray. Just pick up the phone. I love that mantra. Just pick up the phone and get in touch with the guys. And even if you can't get someone straight away, we'll get back to you. So
we love that. We love that napkin CAD, you know. So if you guys you can jot it down real fast and shoot a picture, we'll usually make it work out a little bit well for everybody. So
Matt from
Daniel, can you put your contact details up on the screen again? Doug would like to see.
absolutely. I'll just shuffle a couple of things around on here, and we can get that up for you. That
Cool.
is not a problem. Yeah, so I'd say thank you to Matt from Valence for listening in there. That's very, very, very kind of you. The guys who generate such magic. But yeah, say get the questions in on email if you need to. My details are up on there. Get in touch with the guys in the right territory. Get in touch with your reps if you have questions that they can get us through. We can help answer there. Yeah, I know we've overrun, so thanks very much for sticking around. It's really, really, really very kind of you. So
What we'll do
fingers
as
crossed to see you again.
Daniel, what we'll do as well is we'll send a link to download this, because some of you guys have been in and out of these sessions. So we'll send you a link so you can watch it in a more peaceful time.
And it should also still pop up in this channel if they are on their teams as well when it's complete. So
cool.
You'll get that external link, and then you'll also get this inside this channel group when you're done. So perfect.
Brilliant. Thank you very much, guys. Are we clear? You guys tell me. I can't see the Q&A anymore. So
yeah, I think we're great. Everybody's dropping off, and so everybody have a great rest of your week. And thanks again, Daniel and Roy.
Nice
you guys have a great one.
No worries.
All right.
Thank you very much, guys.
Take
Cheers
care,
now.
everyone. All the best.
Cheers,
Bye-bye now.
Thank you.